In this lesson, we will calculate the time for a sample to decay and describe the general process by which radioactive dating is used to determine the age of various objects. The half-life of radon-222 is 3.8 days. What mass of an 80-gram sample will remain after 19 days? We're going to start with 80 grams, and this is the amount that's present when time equals 0. After one half-life, we will have 40 grams of sample remaining, and this will occur at 3.8 days because that's the half-life of radon-222. Next, we will go to 20 grams, so a second half-life, the length of which is also 3.8 days, so two half-lives would be 7.6 days. Next, we go to 10 grams. We add another half-life, so add another 3.8 days for a total of 11.4 days. Then we go to 5 grams, and that's a total of 15.2 days. Then we go to 2.5 grams, and that's a total of 19 days. Each arrow drawn here in purple represents a half-life, so we can see that we have 5 half-lives for the sample to go from 80 to 2.5 grams. Because each half-life is 3.8 days, this is a total of 19 days. A sample of strontium-90 decays to 1/16 of its original value after 87.3 years. What is the half-life of strontium-90? Even though the amount is given as a fraction, we will treat it the exact same way as if we started with a mass. At time equals 0, we say the fraction that's present is 1. After one half-life passes, we will have 1/2 of the original amount, whatever that amount was. After a second half-life, we will have 1/4. A third half-life is 1/8. And a fourth half-life will be to 1/16. It takes 4 half-lives to get to 1/16 of the original value, so there are 4 half-lives that have passed. We know that each half-life is the same amount of time, so we can say 4 times the half-life is equal to the total time, which was 87.3 years. If we divide both sides by 4, we get half-life is equal to 21.8 years. Seaborgium-245 has a half-life of 4.5 milliseconds. If you have a 1,024 gram sample, how long before only 1 gram remains? As before, we will start with our initial amount, which is 1,024 grams. After one half-life, we will have 512 grams, then 256 grams, then 128 grams, then 64 grams, 32, 16, 8, 4, 2, and 1. Now we need to determine how many half-lives have passed because we've seen that we can get from 1,024 grams to 1 gram. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 half-lives have passed. Now we know 10 half-lives have passed. We know each half-life is 4.5 milliseconds. Our total time t will be equal to 10 times 4.5 milliseconds, so it will equal 45 milliseconds. Let's look at this graph to understand how carbon dating or other types of radioactive dating works. In a living object, the carbon-14 levels are relatively constant. When something is no longer living, the carbon-14, but not the carbon-12, will decay. And carbon-14 will decay to form nitrogen-14 and emit a beta particle. By knowing the ratio of carbon-14 to nitrogen-14, we can understand how old an object is, or more specifically, how long since an object ceased to live. In reality, carbon-14 is a very small percentage of the carbon in any object. To make the decay easier to see in our example, we're going to pretend that carbon-14 is present at 40% in any living object. After one half-life, half of the carbon-14 would have decayed to form nitrogen-14. So after 5,730 years, which is one half-life of carbon-14, we see that instead of having 40% of carbon-14, we have 20% of carbon-14. After a second half-life, we've gone from 20% to 10%. Another half-life leads us to 5%, then 2.5%, then 1.25%. Notice that each half-life has a length of 5,730 years. If we have gone through 1, 2, 3, 4, 5 half-lives, the total time would be 5 times the half-life of carbon-14, and that's equal to 28,650 years. The carbon-12 carbon-14 ratio is 1/8 of its original value. What is the age of the object? We're not given a percentage or even an actual amount, we're given a fraction, which means we're going to start with 1. After one half-life, we will have half of the original amount. After another half-life, we will have 1/4. And after another half-life, we will have 1/8. Therefore, we have 3 half-lives to get from the original amount to 1/8 of the original value. We know 3 half-lives have passed, and for carbon-14, each half-life is equal to 5,730 years. So we see 3 times 5,730 years is equal to 17,190 years.